Hello students, hope you are doing well. I'm going to record this video on the topic graphs and transformations. So if you can look up on my screen, I have these various graphs drawn on the same screen. And the basic one, the parent function right here is the red one, red graph, which is y equals x square. Now the black graph, which has shifted down, is the graph of your y equals x squared minus 3. So when you subtract a function, when you subtract a number, a constant from a function, it goes down. Then you have the blue graph, which has shifted up 3. So if you add a number to a function, it goes up 3. Then if you have x plus 3, if you just change the x, not the entire function, just change the input to x plus 3 whole squared, then it moves to the left by 3 units. And if you have x, if you subtract the input, if you subtract just the x value by 3 units, it moves right by 3 units. So as you can see, the green graph has moved left by 3 units. The purple graph has moved right by 3 units. The black has gone down 3 units and the blue one has gone up 3 units. Then let's look at this absolute value function. I'm going to upload this recording in the discussions. So the absolute value function right here, the parent function right here is your red graph, which is y equals absolute value of x, or y equals, that's how we denote it, y equals 2 bars and x. It always stays positive. Okay, one other thing I wanted to note here in the above graphs is domain and range, but let's look at this example first. So again, it's the same thing. The black has gone down 6. So what I'll ask you to write in the discussions is just write these answers. The answer to what's the equation of the black one? What's the equation of your green one? So equations of black graph, then green graph, and then you have your purple graph and blue graph, purple and blue, and the blue graphs. So write all those equations in the discussions. And then one other thing I want to cover here is the domain and range of all of these functions. For example, the black graph right here has your if you look at the domain and range of the black one right here has gone down 3. So the domain of the black graph is still negative infinity to infinity. Let's write down domain here and range here. But the range of your black one is your now negative 3 to infinity. Now I'm hoping you know the domain and range for the red one. Now for the red one, the domain and range are the domain is negative infinity to infinity, whereas the range for the red one is 0 to infinity because it stays above x-axis. The function is always positive, including 0. Now for the blue one has gone up 3 units. So the domain for the blue one is still, the domain doesn't change here. It's negative infinity to infinity, but the range now for the blue one is 3 to infinity. The green graph has just moved left and right. It hasn't moved up and down, green or the purple one. So the green and the purple one, for both of these, the domain and range are the same. The domain doesn't change. It's negative infinity to infinity for both. And the range, since it hasn't gone up and down, the range for both is also 0 to infinity. So do the same thing with this graph. Answer the functions first and write the domain and range for each of these in the discussions. Then let's look at the next one, which is my y equals square root of x. Here my parent function is the red one again, y equals square root of x. And if I want to write the domain and range of my square root of x function, it's always positive. The output is always positive, and the input inside the radical, I can only input positive numbers. So the domain of this red function is 0 to infinity, and also the range is 0 to infinity. Let's look at if it goes up 6. If it goes up 6, I have still radical on my x, and x can take any positive value and 0. So the domain stays the same. So the domain here is 0 to infinity, but the range, since it has gone up and down changes the range. Since it has gone up, the range now is 6 to infinity. Now let's look at the purple one. If I look at the purple one, purple one has gone to the right, right? It has gone right by 4 units. So the domain changes now. It's starting from 4. I cannot input any number less than 4. If I input 3, it's going to give me a negative under the radical. So of course, I have to input any number 4 and up. And since it has only moved left and right, the range won't change here. The range will still be 0 to infinity. Now let's look at the black one. Black has gone down 6, but it's still starting from 0. So the domain for the black one is 0 to infinity, whereas the range for the black one is now negative 6 to infinity. Now let's look at the green one. The green one is starting from, I don't see it. The green one is x plus 4, not plus 6. The equation is wrong. So this one is square root of x plus 4. It has gone 4 units to the left. So that's the equation. Now the domain for this one starts from negative 4 to infinity. You can input negative 4 and anything beyond negative 4. Whereas the range, since it starts from 0, the range is 0 to infinity. Okay, so the next graph, as you see here, is I have done some stretches and reflections. So if you see, the parent function is y equals x cube here, which looks like this. Um, the parent, let me draw it, a small version right here next to it. So y equals x cube looks like this. The domain and range for this function is negative infinity to infinity and negative infinity to infinity, domain as well as range. When I do when I multiply the graph by a number between 0 and 1, it compresses the graph. So as you can see, the green version is the compression. So that's the compression, right? Because it's going down. It's slowly rising. It's not going as fast as the red one. Then you have the blue one, which is a stretch. I can input any number here. I used a 6. I can input 8, 10, 100, 600, million, 2, 4. Any number more than 1, a more than 1, it's going to stretch. Stretch means it's going to go faster. So this one right here is my stretch. And any number between 1 and 0 and 1, it's going to compress. The other thing is reflection. As you can see, the purple graph is the reflection of the red one. So right here, the purple. Now, reflection occurs in two ways. It could be reflection about x-axis or y-axis. If I put a negative in front of the function, now in this case, it's the same. Let's see how. If I put just a negative in front of the function, that reflects about x-axis, right? Now, in this case, in this particular case of y equals x cube, you reflect about x or y. It's the same thing, because if I have this given function and I reflect about x-axis, let's use another color. If I reflect about my x-axis, it's going to look like this, right? And, and if I reflect about y-axis, it's still the same. So in this particular case, reflection about x and y is the same. But how do we write the equation? If you put just a negative in front of a function, it gives the reflection about x-axis. However, if you just input your negative x for x and write this, this is your reflection about y-axis. Now, if you look in this case, negative of x cube is nothing, because negative cube is negative 1, is nothing but negative of x cube. So in this particular case, both the reflections are the same, as both the equations are coming out to be the same. Now let's look at another example right here. Problem 1 right here. For the graph, write the equation for the reflection of this function about x and y axis. So my function given is y equals square root of x. If I want to reflect about x-axis, I would simply do y equals negative square root of x. And my function, your parent function, looks like this. So reflection about x-axis will simply be this, negative square root of x. Now, if I want to reflect this function about y-axis, then my original graph is right here, right? That's my square root of x. If I want to reflect it about y-axis, I need this. That's my reflection about y-axis. Now, what will be the equation of reflection about y-axis? Equation will be square root of negative x because you're inputting negative numbers, right? So this is my square root of negative x. Um, that's my y-axis and this is my x-axis. Now, in this case, the domain and range also changes for all. For example, this blue graph right here, this blue one right here, the domain, let me take another bus. So the domain of this particular graph right here is 0 to infinity. It's on the positive side of your x-axis. However, the range of this particular graph is negative infinity to 0, right? Similarly for the purple one, the domain, it's on the left side of x-axis. So the domain is negative infinity to 0, right? But the range for this one is 0 to infinity. Okay, so hope this makes sense. The next one I have is draw the graph of 3x minus 2 whole squared plus 7. The first thing to note here is how many transformations do you see here? I see 3. So the first one is the stretch, which I have labeled here. It's stretching. The parent function is x squared, right? It's stretching by 3. So 3 x minus 2 whole squared. It's going right and then it's going up 7, right? So stretch by 3, shift to the right, and then 7 up. So as you can see, the graph of this function right here, if I have to draw step by step, I would first stretch my function 3, and then I would shift it to the right 2, right? The stretched version, and my function doesn't look that stretched, but then I would move up 7. So what will be the domain of this function? The domain, since it is extending left to right indefinitely, the domain is still negative infinity to infinity. However, the range changes because it has moved up 7, so the range is 7 to infinity. The other thing which I have tried to find here is the y-intercept. How do you find the y-intercept? When is this blue graph going to cross your y-axis? For that, you set x equals 0. If my x is 0 in that function, that's my x, the place of x. I have 0 minus 2 squared, which is 4. 3 times 4 is 12 plus 7, which is 19. So 0, comma 19 is my y-intercept for this particular function. It's going to cross somewhere here where your 0, comma 19 is. Okay, the next one is draw the graph of negative of x plus 2 plus a 5. So again, I see 3 kinds of transformations. It is reflected about x-axis because negative is outside. Then it has shifted to the left by 2 and up 5. I have drawn all these right here. Reflection, first step. Second step, shift to the left. Third step, shift up right here. So this is your graph right here, negative square root of x plus 2 plus 5. Now this point right here is negative 2, 5 because it has shifted left 2 and up 5. Now what is the domain of this function? The domain of this function is, um, as you can see, it starts from negative 2 now. So negative 2 all the way up till infinity. And the range, it goes down indefinitely, but the highest point is 5. So negative infinity to 5 because it's going down indefinitely it's going down. These kind of functions are also called decreasing functions. It is decreasing in its domain. It's always going down. But we can cover that later. Now the other thing I wanted to show you right here was the y-intercept again. So if I have to find the y-intercept for this function, I would set x equals 0 in the original question. So y equals negative square root of 0 plus 2 plus 5, which is negative 0 plus 2 is 0, plus 5. So it's nothing but 5 minus square root of 2. And if you use your calculators, square root of 2 is 1.4 something, and 5 minus 1.4 is 3.6. So it's going to cross right here, somewhere right here where it's 3.6 something, approximately 3.6. So hope this makes sense. Again, I encourage you to post this equations and their domains in the discussions. And if you have any question, to let me know. Take care. Bye bye.